So the next Bluebook test preview multiple choice for Calc BC asks us to identify which of the following series is conditionally convergent. So you obviously have to know what conditionally convergent means in order to have any success with this. So a series that is conditionally convergent requires the alternating condition to remain present in order to converge. In other words, if you take the absolute value of the rule for the series, that eliminates the alternating condition. All terms would then be positive with absolute values applied. We would want to see a series where it diverges when that happens, but if the alternating condition is allowed to remain present, we then are looking at a series that converges. Now, the first thing that I noticed here is I noticed that both of the rules for these series in options C and D, think about, without necessarily even involving the alternating portion, think about the limit as you approach infinity of 5k over k plus 1. That's going to have a limit of 5. These terms do not become closer and closer to 0 as the index gets larger and larger and larger. These terms become closer and closer to 5. I'm not going to be looking at a series that ever converges if the terms in the series don't approach 0. You might call that the kth term test for divergence or the nth term test for divergence, depending on your textbook. Similarly, this one, and I have the wrong exponent here, but it's the same conclusion. 5k squared over k is going to have a limit of infinity as the index approaches infinity. For the same reason as C, this one's also going to diverge. So we can eliminate those two very quickly. Now, if we have it boiled down to either option A or option B as the one of these that's conditionally convergent, what we would want to do is we would want to take the absolute value of those rules, which basically eliminates the alternating component, right? So I just have 5 over k plus 1 for option B. I guess this is B that I have initially here. And then 5 over k cubed plus 1 for option A. Think about this as the rule for a series. This is not technically the harmonic series because of the 5 here and the plus 1 there, but it's going to behave a lot like the harmonic series. If I wanted to break out the limit comparison test, or even the integral test, I could show that this series here is going to be one that diverges. But this series here, using a limit comparison test with maybe 5 over k cubed, a p series that converges, this series is going to converge by using that test. The absolute value of the series in choice A converges, not diverges. A is absolutely convergent, not conditionally convergent. When I allow the alternating condition to remain present in option B, I have a series that behaves very similarly to the alternating series test. Now, we haven't really formally done a proof of convergence or divergence for anything here other than C and D, but we have identified A as being absolutely convergent, B as being conditionally convergent, meaning take the absolute value, you diverge, but allow the alternating condition to remain present, and you converge.